Oil flow begins in the oil pan, which is the reservoir for holding the engine lubricant. At the bottom of the oil pan, there is a strainer, which is the pickup for the oil pump. As the engine is started, oil flows through the strainer into the oil pump. The oil pump pressurizes the oil and forces it through the oil filter. The oil filter is responsible for removing particles carried by the oil. Oil enters through several ports around the perimeter of the filter, is forced through the filter element, and then leaves the filter through its center opening. From the oil filter, the oil goes to the main oil gallery. The main oil gallery feeds the pressurized oil to the main and rod bearings. The main bearings are lubricated first. Then, drillings in the crankshaft route oil to the rod bearings. Also, oil from the main bearings is routed to the camshaft bearings through drillings in the block. Okay, so far we've seen how the bearings are lubricated. You should have noted that the bearings were all pressure fed. Now let's take a look at how the upper engine components are lubricated. Off the main oil gallery, there are two other small galleries which feed the hydraulic lifters. The lifters need this oil to maintain zero lash and also to lubricate the upper part of the engine. In this design, the upper part of the engine is lubricated by oil that travels through the hollow push rods from the lifters. It functions in this manner. Oil flows into the lifter from the oil gallery through a hole in the lifter body and plunger. There's also a hole in the push rod socket that allows pressurized oil into the push rod. While the lifter is on the base circle of the camshaft, oil is allowed to flow into the oil chamber beneath the plunger. As the camshaft turns and the lobe contacts the lifter body, the pressure on oil in the lower chamber forces the check valve closed, making the lifter a solid component in the valve train, and the lifter rises. Although there is no more oil flow into the lower chamber, there is still oil flow into the upper chamber and out to the push rod because the check valve does not close this chamber off. From the push rod, the oil sprays out over the rocker arm and other valve train components. This spray coats the upper engine components with oil to provide the necessary lubrication. Now, what I want you to note here is that lifters were pressure lubricated, but the upper engine components, meaning the rocker arms, valve springs, are lubricated by the oil then drains back from the cylinder head pan. That's how the basic lubrication system works.
But JC, you left out some parts. How are the camshaft lobes, pistons, cylinder walls, timing chain, and piston pins lubricated?
Well, that's a good point, John, and I was going to get to that. As the engine is running, a certain amount of oil is escaping from each of the bearings and is sprayed throughout the engine, or is dripping downward from the force of gravity. It's this spray and dripping which provide a lot of the lubrication for the camshaft lobes, pistons, cylinder walls, timing chain, and gears, and the piston pins. In addition to the spray that typically comes off the bearings, some engines are designed to provide a more direct spray of oil to the cylinder wall through a squirt hole in the connecting rod, which provides a spray of oil under the cylinder wall as the engine runs. The excess oil on the cylinder wall is scraped off by the oil control ring and drains through these return holes cut in the piston ring groove. The splash of oil coming through the return holes is what lubricates the piston pin. Some diesel engines used by Ford lubricate the piston pin with pressurized oil rather than by a splash. In these applications, the connecting rods are rifle drilled. This rifle drilling allows oil to be routed to the connecting rod piston pin bushing from oil passages drilled in the crankshaft that feed the rod bearings.
Well, I see how the major components of the engine are lubricated, either by direct oil pressure or by some method of spray or dripping. But I'm confused about all the different engines. There's overhead cams, dual overhead cams, rocker arm shafts. There's all kinds of differences.
Well, those are good points. But what you've got to remember is that typically there is a basic feed pattern. Now, here's the basic feed pattern. Oil pan to strainer, to pump, to filter, to bearings is pretty well set and won't change much between engines. It's the upper part of the engine where you'll see differences. And really, You brought it up yourself by mentioning the different upper engine designs, like the overhead cam, dual overhead cam, and rocker arm shaft. These components, like any other, must be lubricated, and it's typically through an oil passage. Let me show you some examples. In this 4-cylinder overhead cam design, you can see there is an oil passage right off the main oil gallery. This passage feeds another gallery in the cylinder head, which in turn pressure feeds the camshaft bearings and lifters. Also note that the camshaft is hollow, and each individual camshaft lobe is pressure-fed oil. The other components, such as the valve components, are lubricated by spray and dripping oil. A point to note is that not all overhead cam engines utilize the hollow camshaft as an oil gallery. In these other applications, the camshaft lobes would be lubricated by spray or dripping oil. In a dual overhead camshaft application, the lubrication happens in a very similar manner. This example shows a V6 dual overhead camshaft engine. Here the oil is fed to each cylinder head through a passageway. Inside each cylinder head, there is an oil gallery which pressure feeds the camshaft journals and lifters. The other components, including the camshaft lobes, are lubricated by spray and dripping oil. Now, the final design you mentioned was the rocker arm shaft.
Right.
In this design, usually the rocker arm shaft is hollow and acts as the oil gallery. Here, oil is routed through a passageway off the main oil gallery to the rocker arm shaft. The rocker arm shaft then distributes the oil to the rocker arm bushings under pressure, and then to the other valve train components in the form of a spray or dripping oil.
Wow, there sure is a lot to these lubrication systems.
Yes, there is. But what you've got to remember is that there's 3 basic lubrication methods: pressure, spray, and drip. Main bearings, rod bearings, and cam bearings will always be pressure-fed. Sometimes the piston pin and rocker arm bushings are too. Typically, other components are lubricated either by spray or from dripping oil.